Why do conversations with computers feel more human than ever? The answer is natural language processing, short NLP. Let's explore what NLP actually is and where it's taking us next. I'm Toni from Diconium Data, and this is Oshada. Could you please tell us a few words about yourself?
Yes, I'm Oshada Kasun. I'm working with Diconium Data here in Hamburg studio and working in the team called Data Engineering and Architecture. So I'm working as an advanced machine learning engineer here in Hamburg office, and I'm joined Diconium in 2023. And yes, we had very good project over here related to data and also machine learning. So yes, that was my background.
Okay, so today we are talking a bit about NLP, short for natural language processing. How did you came across this topic, and can you explain it briefly to me?
Yeah, in short, it was started with hopeful translation. Then it hit the wall. See, this translation not good enough. Especially these things was happened 1950. The idea of translation came, and then 1960 decade, these people see this not gonna be accurate as we expect. Then funds are right down. Then 1970s gradually started to focus on small part of languages. Then there's a notable one with 1974 with Schroeder model, which is able to have some real understanding on a tiny universe called block world. Then when it comes to 1980, people tend to believe that rather than going with this rule-based approach, it's better to go with data and statistical approach, whether this model can actually learn language patterns, especially through data. And yeah, that's how it was in first 40 years.
Yeah, first 40 years, we ended in the 80s, now 90s. What's happening then?
Yeah, in this decade, this momentum shift to machine learning was happen because at this time was the people tend to use this machine learning techniques significantly into NLP. We can mention notable models like hidden marker model, support vector machines, which was able to handle tasks like part of speech tagging and sentiment analysis. And also this was the time having the groundwork for a basic statistical machine translation. And when it comes to 2000 and 2010, those 2 decades was the time deep neural network and neural network kind of topic comes. Even though the neural network have a long history, this was the time actually it make real impact and widespread adoption to NLP.
Yeah.
Especially with the notable algorithm called recurrent neural network, long short-term memory, and gated recurrent units, and also most notably the transform architecture, which propel NLP field to a next era of innovations.
Yeah, so the history is much more longer than I would expected it to be. And you mentioned transformers. What's transformers exactly? How did it evolve?
Yeah, transformer was introduced in 2017 by Google researchers with the paper called Attention All You Need. So before introducing this model, the earlier approach was with these dominant architectures of recurrent neural network, and its variants was this sequential processing. It's like things like we human going to communicate with each other. So we tend to go with word by word, then going for sentences, and then paragraph or kind of thing. That's how we're going to explain something to someone. That's how we're going to communicate. This was the approach. Actually, this model used to train. So that's why it actually taking longer time to train. So normally people found it's slow training, and we could not use the parallel processing. It was really difficult to use, even though we have the good resources with GPUs. Another issue with this long-term dependency, that means understanding the representation of words, how it related to every other word in the sequence was difficult. Let's say there is a pronoun which is related to a noun, maybe earlier 20 words in a sentence. it actually loses the context. It's really hard to understand what these pronouns mean. So because there is a issue called vanishing gradient, which is oftenly saying it's already going to forget what was happened earlier in the context. So with this long-term dependency also, there's another issue called less contextual understanding. Actually, the globally processing, words simultaneously for particular context was hard. And these words are actually tend to go with its immediate predecessors, and it really did not get the whole idea of the whole sequence. So also with these three issues, there is another issue called scalability. Practically people would not able to train with massive data sets and also with longer sequences. So this was the issues that Transform addressed with this self-attention mechanism. With the self-attention mechanism, we can able to train the sequence at once. It's not going to process word by word. It's going to process whole word at once with this parallel processing. With the use of this, people can get the use of GPUs, which is good with parallel computations. And then when it comes to this long-term dependency and less contextual understanding, it also addresses with this transform architecture, because it has a word representation to every word pair in the sentence. So then whatever the word we pick and any reference there after maybe 100 or 1,000 words away, this still can understand what it means. So with this, we were able to train this model with massive data set, also even with longer sequences, longer sentences, which actually gives a good platform, good platform to build a foundation and pre-train large models like LLMs that we are currently using.
Okay, so Transformer was already doing it more advanced, I would say. And LLMs, are they even more advanced? What are they? When did they came up?
Yeah, once the transform architecture was released, the researchers realized that we can train this model with vast amount of unlabeled text, especially with this internet data, and make this model able to do the general language task, and especially understanding these language patterns and understand this grammar and common sense kind of stuff. Then if we wanted to make this model for specific tasks like semantic analysis, question answering, or maybe text summarizations, we can do it less amount of label data with fine-tuning this model further for those specific tasks. This was the idea behind these foundational models. Especially foundation models are the large pre-trained model. Then we get use of these foundation models to train or maybe get use of for our specific tasks. So there are notable mentions, especially in 2018, there was a model released BERT, which also from Google, 2018. And also the same year, OpenAI also released GPT model. These two models are two type of transformers. BERT was encoder only model, and GPT was a decoder only model. This decoder only model actually laid the foundation to current generative AI, especially when it comes to NLP. The decoder-only model means it's just going to predict the next words of the sequence, and it actually can generate more coherent human text. So it also further fine-tuning to question answering or summarization or whatever the task we are currently using it for our content writing, also through our coding also.
Okay, cool. So we looked at the history, about the recent updates, and where do you see NLP in the future?
Yeah, in future would be some exciting work would happen, especially with the true multimodality. Beyond text, we can work with this model with more images, videos, and audios, or maybe more sensors data. And also, especially, I think it would more deep and nuanced understanding with this model. Below surface level, this can understand maybe common sense and maybe more reasoning. It's still also having this reasoning part, but I think it would be improved further. And also to understand this human intelligence or human emotions, especially the sarcasm and also the tone of the people using, and also maybe accent in different cultures. It can evolve in that area, and also especially for considering the language which has low resources in internet would also make good improvement, because currently these models are very good with English, but I think the same performance level would achieve with other languages which having very less resources in this digital context.
Okay, so you already mentioned like cultural things, different, yeah, things that make humans different. So what's your take on biases, and how can you approach fairness in the development of these technologies?
Yeah, when it comes to bias, because this model trained with internet data, so this internet data also created by human.
Yeah.
So human, sometimes oftenly when we writing something, the stereotype for gender, race, or maybe any other group, it can bias. So the best thing is, while we training this model, we have to be cautious. We have to use more fair data, and also while training process, also we need to make sure this model will not train on this kind of way. So we can monitor it, and also we can monitor the output. We can review the output by human and use it for more fair way. So in that case, I think this could be more fair enough to use with everyone, because this technology is really good to use for our day-to-day work, but it's also having this kind of fairness, then everyone else can use this for their work.
Okay, so yeah, that was a deep dive in the topic of NLP, transformer, LLMs. Thank you very much for joining me today,
Yeah,
and
thank you.
see you all next time.